யாசிக்கப்பட மாட்டாங்க.
ஸ்கிரீன் ஷேர் ஆயிடுச்சு. ஆமா சார். வந்து சார் இப்போ ஸ்கிரீன் தெரியுதா சார்? பாருங்க. ரிசீவ் பண்றதுல ஸ்கிரீன் தெரியுதா? உங்க இதுல பாருங்க. ஷேர் ஆயிடுச்சு. நீங்க ரெஜிஸ்டர் பண்ணிருக்கீங்களா நீங்க? நான் ரெஜிஸ்டர் பண்ணல சார். ரெஜிஸ்டர் பண்ணிருந்தா வரும். ரெஜிஸ்டர் பண்ணி ரிசீவ் பண்ணணும் சார். இல்ல அவர் கண்ணன் சாருக்கு இல்லாட்டி அங்க ரிசீவ் ஆயிடுச்சான்னு சார். யூடியூப்ல வருதுன்னா சார் லைவா சார்? ஸ்கிரீன் ஷேர் ஆதான் பாருங்க. ஸ்கிரீன்ல வந்து okay. ஹலோ கேக்குதா? ஹலோ ஓ ஹலோ ஹலோ
சார் கேக்குதாங்க
சார்? கேக்குதுங்களா சார்? நாங்க சார் ஒரு சின்ன டவுட் சார்.
சார் சொல்லுங்க
சார். இதுக்கு இப்ப அந்த ரெக்கார்ட் பண்றதுக்கு ஆப்ஷன்ஸ் எப்படி சார் போணும் சார்?
ஒன்றும் இல்லை சார். அதுக்கு பக்கத்துலேயே உங்களுக்கு நேமுக்கு பக்கத்துலேயே வந்து இது ரெக்கார்டுன்னு ஒரு ஆப்ஷன் இருக்கு பாருங்க சார் கீழே.
இல்லை சார், இது ஸ்கிரீன் சின்னது பண்ணி வச்சிருக்கேன்.
ரைட் சார். கீழே எஸ்கேப் கொடுத்துருங்களேன் சார் ஒரு தடவை. சார் இப்போ பாருங்க சார் கீழே இருக்கா? சார் கீழே ரெக்கார்டுன்னு ஒரு ஆப்ஷன் இருக்கும் பாருங்க.
ஓகே சார்.
அதை கிளிக் பண்ணுங்க சார்.
கொடுக்குறேன் சார். கம்ப்யூட்டர் கிளவுட்ல கொடுக்கணுமா சார் ரெக்கார்டு?
சார் இல்ல சார் கம்ப்யூட்டர்ல கொடுத்துருங்க.
ஓகே ஓகே.
ஹலோ சார்.
எஸ்
சார் கொடுத்துருங்க சார். ரெக்கார்ட் கொடுத்துறீங்களா சார்? ரெக்கார்ட் ஆகுது சார். எஸ் சார்.
ஓகே
ஓகே சார். ரைட்
சார். நல்லா இருக்கீங்களா சார்? ஓகே சார். ஓகே சார். சார் கேக்குதுங்களா வாய்ஸ்? கேக்குது. இது போயிருங்க, ஸ்கிரீன் போயிருங்க. இதுக்கு வீடியோ சார், இதுக்கு பவர் பாயிண்ட் பிபிடி க்ளோஸ் பண்ணிட்டு மினிமைஸ் பண்ணிட்டு பிபிடி டெஸ்க்டாப்ல இருக்கு சார். கரெக்ட் கனாட் மினிமைஸ். அப்போ இது பவர் பாயிண்ட் பின்னாடி இருக்கு. இதுல சார் மினிமைஸ் பண்ணிக்கங்க சார். கண்ணன் சார் சார் மினிமைஸ் பண்ணிக்கங்க சார் ஸ்கிரீனை சார்.
சார் நீங்க உங்க இதை எடுங்க சார். ஸ்கிரீன் ஷேர் ஸ்கிரீன் கொடுங்க சார். கிளிக் பண்ணிட்டு டெஸ்க்டாப் கிளிக் பண்ணீங்கன்னா வந்துடும் சார்.
கொடுத்துட்டு சார் ஷேர் ஸ்கிரீன் சார்.
கொடுங்க சார்.
கொடுத்துட்டு சார்.
இல்ல வரலீங்களே சார். இன்னும் ஷேர் ஆகலையே.
சரி
எஸ் சார் வருதுங்க சார். எஸ் சார். ஷூர் வந்துருச்சுங்க சார்.
ஓகே.
எஸ் சார் வந்துருச்சுங்க சார்.
Good afternoon. I take this opportunity to thank the organizers of this program, Agilan sir and Jayapal sir of Anna Science Planetarium, Anna Science Center, Planetarium of Trichy. And the topic assigned is uses of laser in day-to-day life. Actually, how lasers are useful in our routine life. We are going to have a share on this idea. And I am Dr. M. Jamal Muhammad Jafar, HOD of Physics in the Department of Physics, Jamal Muhammad College, Tiruchirappalli. And we can share some information that I have learned through my PhD work. We can have a glance on this. I am going to have a backward view of my past experimental work. Actually, laser, it is a word we are supposed to have every time. We are supposed to have a glance on it, because Laser stands for, everybody we know, that is light amplification by stimulated emission of radiation. It is actually an acronym. It is not abbreviation. Actually, we are supposed to know the difference between acronym and abbreviation. Abbreviation means, for example, MA, Master of Arts, BA, Bachelor of Arts. We are supposed to say like that. Whereas in this particular acronym, we are not supposed to spell as individual letters, not BA, MA, just like that. Here we are not spelling it as LASER. We are not spelling like that. We are spelling as laser. Acronym, actually, it is a collection. We are supposed to say as a word, not as letters, individual letters. We have to spell as individual word. Actually, acronym itself, it's an acronym. That is, it stands for a concise reduction of nomenclature yielding meaning. That is, it is a method of reducing the nomenclature, which will give you a common name. For example, laser, maser, razor, sonar, all these things, they are acronym. They give their own meaning. The sonar means sound navigation and ranging. The radar, radio waves reduction and ranging, just like that. We are having laser as light amplification by stimulated emission of radiation. It stands for it. And the next thing, that is, yes, here we can have a glance on the difference between the polychromatic light, which is having multiple colors. Of course, we can see, have a glance on pink, orange, green, purple, blue, all these colors we are having. That is polychromatic light. Whereas a monochromatic light means it will be having same color. Of course, we are having here orange color means yes, we are having a same color, same wavelength, but it will be having a deviation. It will not be spreading, it will be having a spreading in different direction. Whereas laser light, they are known as coherent light, which will be having continuous exposure and it will be having coherence, same wavelength, it will be traveling in the same line, same direction, same angle without any deviation. Okay. And this is difference, that is ordinary light and polychromatic light, monochromatic light. Laser will be having highest traveling distance. It has a high traveling distance nature. And this slide shows the difference between an incandescent lamp and laser beam. Actually, they are incandescent lamp, which is emitting different light frequencies and they are diffused in all directions. Whereas laser beam, they are having single light frequency and they are in phase and they travel in same direction. That is the main difference between incandescent light as well as the laser beam. And here, laser versus time. Actually, Einstein was the first person who has given a concept as stimulated emission, which was the base for laser. And Mayman has constructed in 1960, he has constructed ruby laser. So from 1917 to 1960, it took a long run. Nearly we are having around 40 years. Yes, it traveled a long time. He has constructed in 1960. And these are the terminologies that we are supposed to know. That is, in laser protection, we are supposed to know some information, that is atom, ground state atom, excited state atom, spontaneous emission, stimulated emission, population inversion, pumping process, amplification. These are the spell words in laser protection. We are going to see one by one. This is excitation. When the atom is in ground state and the electrons are available in their orbit, when any photon falls on that, the energy in the photon will be absorbed by the electron and the electron will be excited to the next higher energy level. From lower energy level to higher energy level, it will be pushed off. Because of the absorption of energy, it will be pushed off. It is excitation. Here we are seeing the energy levels, that is ground state and excited state. Energy level, ground state energy E1, excited state energy E2, and number of atoms in the ground state is N1, number of atoms in the excited state is N2, and a photon is falling on this particular atom. So what will happen? The ground state atoms will absorb the energy and they will be excited to the excited state, that is E2 state. This is known as absorption. But when this thing will occur, when number of atoms in the ground state is more than the number of atoms in the excited state. So N1 should be greater than N2. It is the case of absorption. And in next case, actually here, the photon is falling on that, so it is going to the excited state. And when it is in excited state, if the photon is cut off, what will happen? The excited photon, actually it will be coming down The excited electron will come down from the higher state to the next lower state by emitting one photon. This is known as spontaneous emission. The energy level diagram is like this. That is, the photon is, incident photon is cut off, and the photon will be emitted in the output. That is E1, N1, E2, N2, same. And in this condition also, number of atoms in the ground state will be more than the number of atoms in the excited state. N1 is greater than N2. So this is spontaneous emission. This is not at all useful for our laser production. Whereas population inversion, we are supposed to have it. That is, when N2 becomes greater than N1, then only we can have stimulated emission and the production of laser we can have. Let us see here. Already the atom, it is in excited state and photon is falling on that. And after falling that, what will happen? The photon will be emitted. Two photons will be emitted. When one photon is falling on that, two photons will be emitted as output. This is actually the case of stimulated emission. And when the stimulated emission will occur, actually number of atoms in the excited state is more than the number of atoms in the ground state. N2 should be greater than N1, which is known as population inversion. And this is the diagram, energy level diagram. Actually, we are having it. That is N1, N2, N3, and N2 is greater than N1. This is the condition which is known as population inversion. And the father of this concept is Einstein. He has framed the base for the laser production with the help of the concept of stimulated emission. Einstein's coefficient and all these things, you may be knowing it. And these are the components which are necessary for the production of laser. In the center in blue color, I have given laser medium, and downwards I am having that is a box excitation source, and on both sides of the laser medium there are two mirrors. One mirror is having 100% reflection and another mirror is partially transparent and partially reflective. So these are the components by which laser output can be obtained. So laser medium, excitation source, and mirrors, and laser output will be coming. So when the laser medium is exposed or excited with excitation source, the laser will be produced and the laser will be oscillating between these two mirrors, 100% reflective mirror and partially transparent mirror. It will be oscillating, and when the resonance is occurring, the laser output will be emitted off. So these are the components which are required for lasing action. That is, to produce laser, we require these components. We are having different pumping methods. What are the pumping methods? We are having several pumping methods as optical pumping, electrical pumping, thermal pumping, direct conversion, inelastic collision between atoms, excitation by chemical method. If light is produced, if light is used for pumping, then it is known as optical pumping. If electricity is used for pumping, it is known as electrical pumping. If heat energy is used, it is known as thermal pumping. Just like that, we are having several pumping methods, and the lasers are classified on several bases. First one is electrical pumping, means example, helium ion laser, carbon dioxide laser, excimer laser, argon ion laser, diode laser. These are the examples for electrical pumping. Optical pumping by lamps. If you use some lamp for producing this excitation, for example, ruby laser, we are using xenon flash lamp. So ruby laser, NdYAG laser, erbium YAG laser, dye laser, alexandrite laser, all these lasers are produced by pumping with the help of lamps. And pumping by another laser. To produce one laser, we are supposed to use another laser for pumping. For example, NdYAG laser, erbium YAG laser, neodymium vanadate laser, and titanium sapphire laser, all these things, they require another laser, low power laser, for producing high laser output. And how lasers are classified according to the lasing medium. If gas is used, then it is known as gas laser. For example, carbon dioxide laser, helium ion laser, argon ion laser, krypton ion laser, copper vapor laser, excimer laser, nitrogen laser. All these things, they use gas as lasing material. And a liquid dye laser is supposed to be the best example for the liquid lasers. Solid state lasers, ruby laser, NdYAG laser, erbium YAG laser, diode laser, titanium sapphire laser, chromium YAG laser, alexandrite laser, all these things, they are using solid state lasing material. And okay, now we can go for the laser applications. How lasers are useful, where they are useful. Actually, I have given a color code. That is for communication, it is up to 40%. 40% of lasers are used for fiber optic communication, and 20% it is used in defense, and 20% it is used in industries, and the remaining 20% is used in medicine. So the maximum utilization is taking place in the case of communication, and remaining things are having their own equal shares. And in the case of laser materials processing, we are having a color code once again. Maximum laser it is used for cutting as well as marking, welding, scribing, and very minimum percentage is used for drilling and surface treatments and others. Now we are going to see the different types of materials processing, how lasers are useful in processing materials, that is to weld, to cut, to drill, or for producing alloying and cladding, marking, scribing, engraving, soldering. All these things can be done with the help of laser. So types of materials processing, it is taking place in these 8 manners. This is a system in which laser is processed. Actually, the blue color sample is kept here. A lens is kept over that. A 45-degree inclined mirror is kept there, and laser source is there. So the laser light from the laser source will fall on the mirror. It will be reflected by 45 degree. It will be focused by the focal lens. That is, it will be converging. Convex lens it will be used, and the laser will be focused on the sample, and the heat energy will be focused on that, and we can have processing. Actually, it is nothing but an ordinary experiment that we have done in our earlier stage. That is, if you take a lens and take a paper, keep the paper in the ground and focus the sunlight with the help of this lens on the paper, immediately the particular paper will begin to burn. That is, the sunlight will be focused on the paper, and it will be having maximum thermal energy which will burn the paper. So this is the basic principle of our laser materials processing also. Laser will be focused by the mirror and lens, and it will be falling on the sample, and we can have the further processing. And what are the lasers used for materials processing? For example, carbon dioxide, ND-OG laser and ND glass laser, diode laser, fiber laser, ultraviolet laser. Of course, it is excimer laser, ultra fast lasers. These are used for laser materials processing. Actually, the laser can be in the continuous mode or pulsed mode. Continuous mode means we can use it for welding, cutting, cladding, alloying, hardening. Whereas the pulsed laser will be useful for having drilling purpose, scribing purpose, cutting purpose, and marking purpose. So depending upon the need, we can use either CW laser, continuous wave laser, or else pulsed laser. And this is the way by which laser is used for cutting. Actually, see, the laser will be focused. The laser will be focused on the workpiece, and it will be cutting. We have given 2 pieces actually. The top one is the cutting with some other conventional tools. So the both surfaces are having ups and downs. Whereas the second one is in the bottom, it is laser cut, which is having sharp cut edge, and there is no ups and down. So this is laser cutting with gas jet, which will be having highest efficiency. And these are the components with which we have used laser for cutting. See here, so many designs they have cut with the help of laser. And these are the tools that we are using in regular life. Laser is used for cutting purpose. Similarly, laser welding. 2 pieces are joined together. Actually, in the conventional welding, 2 pieces will be there, and they are going to be joined with the help of a welding arc, and the filling material we are supposed to place it. So after welding, both ends will be, for example, aluminum means the center will be having some filler material. It will be having different quality, and it will be having different material characteristics. So it is a different type of material in the common material. So it is a drawback actually. Whereas in the case of laser welding, see here, the both ends they will be passing laser. Both the ends will be melt, and they will be joined together. Here also we are having 2 surfaces. Top one is conventional welding, and the bottom one is actually laser welding, which is having sharp connection. There is no need for vacuum procession, and they are it is faster processor, and no filler material is necessary, and the contamination will be reduced. So these are the advantages of our laser welding system. These are the weld components with which we have used laser for welding purpose. Very complicated and precise welds can be done with the help of laser. And this is for laser drilling. Micro holes are produced in the laser drilling. different sized holes can be produced even on thin metallic sheets. See here, it is a burner actually, and the burner with the very small, minute holes to big holes they are used. So drilling can be done with the help of the, and it is specially made for producing micro holes. And laser engraving on the surface of even plastic, we can engrave it. This is the example for laser engraving and surface modification. Actually, this is the field which is very useful in space materials because every country is thriving for space adventure. And even recently, China has launched a space rocket to go to what's that? In the they have sent that, and once again they received back on the next day they are received. To that much level, that each and every country is having the adventure on the what's that, on sky. For that we need only lightweight materials. If aluminum is used, it is better, but the problem is aluminum is having poor properties. What are that? It is having so many drawbacks. Aluminum is having drawbacks, but at the same time, due to lightweight, it can be used. So surface modification is used to improve wear resistance, corrosion resistance, oxidation resistance, and erosion resistance. And aluminum is having specialty as low density, high specific strength, good workability, etc. But drawback is lower hardness. 30 to 100 HV only it will be having. Whereas if you use a stainless steel, means the hardness will be more and wear resistance also more. But the problem is weight is more. It is not having low density, it is having high density. So aluminum is having plus points as well as some negative points also. Now we are supposed to improve the hardness as well as wear resistance by laser material processing. Actually, laser surface modification is, that is, laser is used. See here, the turbine blades are here, and the turbine blades are treated with laser. And the laser, it is improving the wear resistance, corrosion resistance, and all this is because this turbine blade is used only in what? In sea. In sea, where salt water is there, and the corrosion will be very maximum, prominent, and predominant. So what will happen? These blades will be having quick corrosion and erosion, and the life of the turbine blades will be reduced or diminished. So to improve the life of the turbine blades, if you use laser and if you treat the blades with laser, and automatically it will be having long life. A turbine blade will have its long life because of its high corrosion resistance, which is going to be inside the seawater. So main application is in submarines and ships and all these things. They are using this turbine blades. And this is the experimental setup which is available in RRCAT, that is Raja Ramanna Center for Advanced Technology in Indore, Madhya Pradesh. Actually, I have completed my PhD work there itself in Indore, Madhya Pradesh. They are India's highest power laser. It is kept there in the RRCAT, Raja Ramanna Center for Advanced Technology, Indore. Actually, it stands the second highest laser power instrument. The first laser power instrument is in USA. And do you know the name of the laser source in USA, which is having its highest power? That is, the name of that is Shiva laser. Shiva laser is the name of the laser system in USA, which is having highest laser power in the world. Actually, Shiva we know the forehead eye, நெற்றிக்கண் லேசர் சிவாவுடைய நெற்றிக்கண்ல இருந்து வரக்கூடிய பொறி வந்து பட்டோனியும் எல்லாமே பஸ்பம் ஆயிரும்னு சொல்லுவாங்க இல்லையா? அந்த இதுக்காக எக்ஸாம்பிளுக்காக தான் the name has been what's that, given as an analogy. That is, Shiva laser has been put up because of the highest burning nature of the laser source. Actually, next to that we are having in India, that is in Madhya Pradesh, Indore, we are having it. Actually, I have done that work, my experimental part there in Madhya Pradesh, Indore, Center for Raja Ramanna Center for Advanced Technology, or else CAT, Center for Advanced Technology. The CO2 laser system is there, and a 45-degree inclined mirror is there, a focus lamp is there, and a shroud gas will be flowing through that. See here in the downwards, in the bottom of the diagram, we are having an XY table. The table can move in, it can be moved in X-axis as well as in Y-axis. So both direction movement can be possible with the help of XY table, and the specimen is kept on that. And above the specimen, a precursor is placed. What is precursor? For example, aluminum I am going to take, actually see here. Yes, this is the laser track on aluminum silicon substrate. The bottom level, we are having a circular disc actually. On that, we are having aluminum silicon base it is having. And above that, I am going to place some material which is having high corrosion resistance, or high hardness, for example, nickel, silicon carbide, titanium carbide, chromium, ferrous, whatever thing may be, which is having a high, what's to say, melting point, high wear resistance, high hardness. All these materials I can paste, I can make a paste and I can coat on that and I can pass laser over that. So what will happen? The laser will melt the materials and a laser alloying will be taking place and the hardness and corrosion resistance will be highly improved. Actually, bottom surface will be aluminum silicon substrate, which is having low density and low wear resistance, low corrosion resistance. All these things will be having, but on the surface, it will be having high hardness, high, what's that, phenomenal factors, that is hardness, corrosion resistance, wear resistance. All the parameters will be improved. So the multiple laser tracks on the precursor, it is shown. So the bottom surface will be aluminum silicon substrate, and above that, we are having multiple laser tracks. See here, the diagram shows the upper layer. There is a layer which is laser alloyed. Actually, bottom surface is aluminum silicon alloy, and the top surface is I have given a coating, and in the 100% coating, 60% is aluminum, 10% is silicon, and 30% is silicon carbide. So aluminum, silicon carbide, they are going to be placed, they are going to be mixed together, and their paste will be prepared, and an adhesive will be added with that, and it will be coated on the aluminum silicon alloy, and it will be exposed to laser. See here, the laser power I have used is 2.5 kilowatt, and the laser will be moved with a speed 0.5 meter per minute, and the layer thickness will be around 100 micrometer, and the energy, laser energy is 300 joules per millimeter square. So here the perfect layer is produced, and if the laser power is changed or the laser scan speed is changed, automatically the layer protection will be disturbed. For example, at same 60 aluminum, 10 silicon, 30 silicon carbide, it is used, but the laser power, instead of, see here in the first part, 2.5 kilowatt, but in second photo, the laser power is 1.5 kilowatt, same scan speed, but layer is not uniformly formed. And in the next picture, laser power is same 2.5 kilowatt, but the scan speed is increased to 1 meter per minute. So automatically layer protection is disturbed. So to have a perfect layer, I should have 2.5 kilowatt and 0.5 meter per minute scan speed, and the power must be 300 joules, and the thickness, it is around 100 micrometer layer is produced with heavy properties. See here, the layer is having hardness around 450 HV, wicked hardness, whereas the base is having around 90 wicked hardness. So in the base, it is aluminum silicon alloy, whereas in the top layer, it is around 450 HV. So heavy HV is increased. So the topmost layer will be having high hardness, which will be useful in the case of our long, it can increase the life of the particular specimen. Similarly here, 20% titanium, 20% chromium, 60% silicon carbide I have used. Power is 2 kilowatt, scan speed is 0.5 meter per minute, and fluence is 120 joule per millimeter square. So a perfect layer is produced, and the layer is having, this is a some photograph of the layer. Silicon carbide, they are distributed, and titanium carbide also, it is having bead structure. The hardness will be highly improved, and the comparison of wear resistances. Actually, the aluminum silicon alloy is having high wear rate. It will be having quick wear. Whereas if you use titanium, chromium, silicon carbide, automatically the wear will be reduced. The wear resistance will be improved, and wear will be reduced, and the life of the component will be increased. Similarly, the hardness. Actually, we are having around 800, 850. 850 wicked hardness is having it, 800 to 850. The base is around 100 only, not even 100, 90 or something like that. So the surface will be having maximum hardness of 800 to 850 HV, which is tremendous, and the life of that particular component will be heavily improved. And wear analysis, it is the comparison between ordinary aluminum silicon substrate, red color, and ferrous chromium silicon carbide, which will be in the black color. So the wear, it will be reduced. So if you use aluminum silicon, the wear will be more. If you use ferrous chromium silicon carbide and use laser for processing, automatically the wear will be reduced. And these are the camshafts produced with the help of laser material processing and all these things. So after this, the industrial applications we have seen. Now we can go for laser in medicine. Actually, when laser is focused on tissues, they heat the tissues and water will be expelled and the tissues will be shrinking in size and die. It is used to destroy cancer cells, virus and bacteria. And it is used to treat retinal problems due to diabetes retinopathy and glaucoma, retinal tear, etc. Everything. Actually, if the retina vilithirai, if the retina is tear off due to heavy sugar and glaucoma, automatically we cannot have a clear vision. So laser is used to treat this, and we are going to put some sutures, laser sutures. லேசர் வச்சு தைக்க போறோம் அந்த கிழிஞ்ச ரெட்டினல் இதை வந்து ரெட்டினாவை தைக்க போறோம் அந்த அளவுக்கு வந்து we are using it, and it is used to perform bloodless surgery, which is a milestone in the case of laser. Actually, when anybody is going to undergo any surgery, the doctor will advise to have some storage of blood of his own group. O positive means O positive or B positive, whatever thing may be. You are supposed to keep some 2 or 3 units in ready, because anything may happen in the time of surgery. Blood loss will be taking place, so we are supposed to make blood prepared. So at that time, what they will do, if they use knife for cutting, automatically a vein or nerve will be cut, and from the cut end, the vein will be cut into 2 pieces actually, and in both sides the blood will be oozing out, and the doctor will be doing his surgery, and after that the blood will be cleaned and the suture will be once again made. So blood loss will be taking place and blood should be transfused. It should be infused for that particular patient. Whereas if you use a laser tool, what will happen? The vein or nerve will be cut into 2 pieces, no doubt. As in the case of ordinary knife, it will be cut into 2 pieces. But at the same time, what will happen? The heat energy will be sealing the both ends. The nerve or vein cut into 2 pieces will be having the sealing of it. Both ends will be closed, and no blood will be oozing out. No blood loss will be taking place. The doctor will clean the surface and he will do the surgery. After that, once again, he will cut both the ends because it is sealed on both ends. So he will be cutting the both sides, and once again, he will be putting some sutures. That's all. So minimum blood loss or even no blood loss will be taking place in the case of lasers. Laser knife, it is actually called as laser knife. And it is used for cleaning the tooth in dentistry, which is actually a cosmetological surgery. It is used for cleaning the tooth, and it is costly also. And it is laser skin rejuvenation. That is, it is a cosmetic surgery. Due to aging factor, actually water will be joined in the tissues, and pigments will be losing its power, and the shrinking will be taking place. When you focus laser, infrared laser on that, the thin layer of skin will be peeled off. It will be removed. The old layer will be removed and the new layer will be coming. It is actually known as rejuvenation. The fresh skin will be growing, so that you can have, even at the age of 60, you can have a glamour of 40 or 30. You can have a look, but the thing is, it is costly. And the pigment present in that particular portion will be absorbing the laser, infrared laser, and the particular layer will be cleaned, and we can have shining skin. Actually, it is coming. It is cosmetological surgery. And laser hair removal. Actually, the pigment, melanin pigment in hair, and it will be absorbing the laser. Ruby laser, it is used for removing the extra hair growth. Actually, it is not for gents in general. Even if it is in the hair in the beard or bush, it is not going to be removed by this. It is for only mainly it is focusing the ladies. Actually, the thick skin, of course, thick skin as well as thick hair, all these things are treated with the help of laser, infrared laser as well as red light laser, because they want to have some shining skin. That is tandem leg, means the unwanted hair will be removed. Actually, a red ruby light is used for this. When it is focused on the skin, the melanin pigment in the hair and follicle will absorb it, and they will be removing it. The hair can be easily removed in that particular place. But the problem is white hair cannot be treated with this, because there is no absorbing component. That is, the melanin pigment is not there in the hair, so we cannot remove white hair. So, and of course, there is no need for removing white hair. Even if at the age of 60 or 70, there is no need to remove the hair. But in young age, they will be focusing on that. So, it is a cosmetological surgery. For removing unwanted hair, laser will be used. And this is also useful for removing the tattoos. Tattoos can be removed with the help of variety of lasers, depending upon the ink present in the tattoo. If I use a red tattoo, of course, I can have a tattoo with the help of some chemicals. which will be having some particular composition, I can use infrared rays, infrared laser as well as ruby laser I can use. So for removing the tattoos, laser will be useful, and lasers in military. Up to this, I have given idea of constructive purposes. Here we can go for some destructive purposes also. Lasers, how they are useful in military. Actually, you can have a glance on this picture. This picture, can you recognize what is this? This is actually modified version of AK-47. AK-47, this terminology everybody will be knowing. AK-47, that is, we know whether it is, do you know AK-47? It is the rifle, actually automatic gun. The expansion for AK-47 is A automatic, K Kalashnikov 47 1947. Actually, it was the gun designed by Kalashnikov, the Russian scientist, Russian designer in 1947, and it is an automatic gun. So up to this, we know AK-47 means it is some symbol. It's not like that. A stands for automatic and K stands for Kalashnikov, and 47 stands for the year of designing, 1947. It is that laser. Recently, it has been modified with the help of lasers. All the gadgets and bullet shields, everything they are treated with laser itself. So the bullets also treated with laser. So this type of modified version laser AK-47 is available. The cost is more, and here laser gun is available. Actually, the laser gun means if you stab a person with the help of a knife, if you pierce the knife into his abdomen, what will happen? All the vein and nerve will be cut, and blood will be oozing out. Blood will be coming out, and he will die out of blood loss. Whereas in the case of laser gun, in that level of laser gun, what will happen? Already I said laser surgery, bloodless surgery I have explained. Here also the same thing. That is what, if you focus the laser on the human abdomen, it will be penetrating the abdomen, and all the vein and nerve will be cut, and both the ends will be sealed. No blood loss will be taking place, but blood circulation will be stopped. Due to stoppage of blood circulation, the patient, the particular person will die. So this is not due to blood loss, but due to loss of blood circulation. So the military gun is using laser gun, and it is used for destructive purpose only. And lidar, already I said sonar, radar, just like that. Lidar, light, distance and ranging. This is like radar. Here laser light is used for finding the distance and the azimuth angle of the particular object lying on that. That is, if enemy's flight is flying, and the laser will be falling on that. Of course, if any flight is traveling our border or something like that, we have to send the laser light. And if it is our country's flight, means the coating given on the flight will absorb the laser and nothing will come back. Whereas if it is enemy's flight, means that material will not absorb the laser, so the laser will be reflected, and the reception of that particular laser will indicate that the flight is enemy's flight or something else. It is not belonging to our country. We can identify that. So with that, the next step we can go for it? We can destroy it or something like that. Okay. So this is for identifying the enemy's flight here, and this is a naval ship in US thing. That is, different lasers are falling. See here, different lasers are focused, and then 360-degree, the enemy's objects can be identified. So the laser is useful in so many places. It is having its own constructive applications, and it is having destructive applications, and all these things. And as a student of science or else a teacher of science, we are supposed to take the plus points as well as minus points of laser. But the thing is, laser is elsewhere. Laser is useful in so many ways and useful in many destructive functions also. It is up to us to decide it, whether we have to use in the constructive purpose way or else in the destructive purpose way. And we have to thank our Einstein for giving the base of laser. Otherwise, I may not be talking about laser, and you may not be hearing about laser right now. So we have to thank the gentleman, the scientist, great scientist, for his contribution of laser, and the people who have worked in laser field. And I take this opportunity to thank the participants for their patient listening, as well as I thank the organizers of this program of Anna Science Center, Tiruchirappalli, for giving me this opportunity to meet you in webinar. And thank you once again. Thank you. It is interaction time. So if you want to have an interaction, means please do it. Kanna, you can enjoy, you can, what is the connect the people, Kanna. Otherwise, you can give the feedback form and they can fill it up and they can give it like this way. Hello?
Good evening, sir.
Sir, good evening,
Your
sir.
presentation is very good. So, can you brief?
Yes. Hello? Hello?
Yeah, sir. Is my voice audible?
Yes, of course, right now. Hello?
Yes, sir. Sir, can you?
Can you only audible for me? Yes, I can. But what I can? Hello?
Brief about how prevent corrosion, sir?
What's that? Hello?
Sir, can you hear me now, sir?
Yes, now.
Sir, can you brief about how can we prevent corrosion in turbine engines, turbine blades to be specific using laser?
Yes. Actually, when you use stainless steel means it can have somewhat corrosion resistance, but when it is kept in the seawater, the highest degree of salinity will corrode it. Automatically, the corrosion will be taking place. At the same time, on the stainless steel, if you use chromium, if you use titanium carbide or titanium, if you place all these things on that and if you treat laser on it, what will happen? The titanium will be melt and the titanium carbide, all these things they can melt and they can form a layer on the stainless steel. So bottom surface will be, the inner surface will be stainless steel, and on the surface it will be having the characteristics of that titanium carbide or silicon carbide or titanium or all these things, they are having high corrosion resistance. So the degree of corrosion will be restricted or reduced. So by this way, they can improve the life of the particular turbine blades. So it is only alloying, laser alloying. By using laser, they can alloy it or clad it. They can directly deposit that particular high corrosion resistance material on it. It is a way by which we can prevent or else we can reduce corrosion. Did you hear me? Hello, gentlemen. Hello. Okay.
Yes, sir. Thank you so much.
Thank you.
Sir, good evening, sir.
Yes, ma, good evening.
Sir, your presentation was really awesome, sir. It is very inspiring.
Thank you, ma. Thank you, ma.
Sir, I just have one small doubt. It is about why is it more difficult and why it is more expensive to create a green laser than to a red laser, sir? We used to get red lasers in local personnel. Is that about the penetrating power of the lasers, sir?
Yes. It is depending upon the quality. It is depending upon the quality and the lacing material also. Lacing material
Yes,
cost
sir.
is more. Lacing material cost is more. That's a problem. It is very difficult to go for the range, color range, different color. Red color we can easily produce. As it due to that only ruby laser was first used. Red color laser was first prepared, isn't it?
Yes, sir.
Yes. The
So
cost is
among us the lasers, which has the more penetrating power? Is the green has the more penetrating power or red?
not, the penetrating power is not important actually, because
Yes, sir.
we are going to use only for surface characteristics only we are using. When you are going to destruct something only, then only we should go for penetration power. For constructive
Yes, sir.
application, there is no need to worry about penetration power. Only thing is the surface density, surface fluence, all these things we require. So for all constructive purposes, there is no need to worry about penetration power. We can
Yes, sir.
concentrate only on the surface energy level. Fluence, it is known as the energy per millimeter square, joules per millimeter square, we can estimate.
Sir,
So,
how satellites? Sir,
yes,
and I have one more question, sir. How
yes,
satellites use laser to communicate with each other?
yes. Actually, laser is having its tremendous directionality. Directionality means it can travel in a single track, in the same lane it will go for it. Actually, NASA scientists, they have kept a laser reflector in moon. laser reflector
sir.
moon, and they have focused laser from ground station from USA. They
Yes,
have they have sent the laser and it was focused towards moon and it traveled in a straight line and it was what's it? It fell on the reflector and it was the laser was reflected and once again it was received by the ground station. So they took the time taken for that upward journey as well as the return journey. From that they can have the time of travel, velocity equal to distance by time. So distance equal to velocity into time. So the time they have substituted velocity of laser is velocity of light. So they have calculated the distance between the earth station and the moon. And
Yes,
they have
sir.
calculated the exact distance actually with the help of laser itself. The distance between the earth and moon is exactly designed and defined by only laser system. Okay. So to that much level,
Yes, sir.
it has highest degree of what's that traveling, the monochromaticity as well as directionality. All this is splendid. So they use for communication. That is, laser light is used for modulation. Laser modulation it is done, and it can travel a long distance between satellites and the satellite to earth. All these communications are possible only with the help of the highest directionality of laser characters, laser beam.
Yes, sir. Thank you, sir. Thank you so much.
Okay, ma'am. Okay, ma'am. Thank you.
Sir, good evening, sir.
Yes. Good evening.
Krishnamurthy from Jamal Muhammad College, sir.
Oh, sir. Hello, sir. Hello.
Past 1 hour, we are shower your wonderful lecture, sir.
Thank you.
Very
Thank you.
nice and informative, sir.
Thank you. Thank you.
My question is, sir,
Yes.
for cancer treatment, we are using laser.
Yes. Yes. Yes.
But
Yes.
in addition, we are facing some side effects, sir. If
Yes.
there is any research is going on without side effect with the cancer laser treatment, sir.
Yes,
Please.
of course. I have done some medical physics in Anna University, so I know to some extent only. I know. So the especially the somewhat absorbing materials they are going to give as a dose, and it will be falling on the cancerous cells, and it will be improving the selective absorption of it. Actually, now we are having so many drug delivery systems. Also, we are having. We are going to deliver that with the help of laser system, laser pulses. Also, we are using, which will exactly focus the laser on the particular cancerous oncological tissues. They are going to focus, and the destruction will be taking place. But there is no 100% avoidance of side burns. There is a possibility of getting it. Of course, if you want to have a clear-cut idea about it, means we can contact our department, Ebenezer. He has done his cancer treatment with the laser. His work is highly focused on laser. On the oral cancer only, he has done it. Oral cancer treatment with laser. So we can have a selective absorption thing. Okay, and come to our department, Isaac Krishna. We can have a general discussion about it. Okay.
Thank you, sir.
Thank you, Krishna.
very much.
Thank you.
Thank you, sir.
Okay, I think that I have reached some of you people. Very good. Thank you. And if there is any more question, means we can answer. Otherwise, we can. Oh. Yes. Hello.
Good evening, sir.
Yes. Good evening.
Sir, your presentation is really awesome, sir.
Thank you.
Sir, I have one doubt, sir.
Yes.
Sir, in this situation, in this corona situation, laser treatment.
I expect a question. I expect because if it is used for killing virus and bacteria, why can't corona? Am I
Yes,
correct?
sir. Yes, sir. Okay.
Yes. I think that if it is possible, means it would have been done. But after this, they didn't go for it. Means I don't know why it is. The research should be started. I think that it will be a progressive research. Of course, if you start it, means it will be a progressive one for you also, ma. Good luck. You can try for it.
Sir,
Yes.
thank you, sir.
If you have it, means clarify, ma.
Sir,
Yes.
sir, your voice is breaking, sir. I can't hear your voice, sir.
Now, can you hear me, ma?
Yes, sir. Now,
Yes. What's your doubt?
sir, the laser treatment is used to, in this situation, corona situation, that question I will ask.
Yes, everybody will be having that. What's the question? Last time also, just I was raised by this question also. They asked the same question. The thing is, the research may be going on. I don't know it, but it is a progressive research. If it is because it is a need of the hour, isn't it? It is a need of the hour. because if it is useful to kill bacteria and all this, the problem is the size of the virus will be a factor. I think so. That's why they didn't go for this analysis, because it is having its very minute dimension, which can't be focused by laser. If I want to penetrate a particular virus or bacteria, it should be greater than the dimension of the wavelength of the source. If I want to penetrate a particular virus, the laser source that I am going to use should have the wavelength less than the dimension of the bacteria or virus. But the problem is this virus is having very minute dimension. So I should design a laser which is having a wavelength which is less than the dimension of the virus. That is why it is not well tried up to this. The size, the smallest size of corona
Okay, sir.
is
Thank
a
you, sir.
safety for it. It is a safety for it right now. Oh, sir, hello.
Thank you, sir. Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Yes, okay.
Professor, can you hear me, Professor?
Yes, I can hear you, sir.
This is Dr. Soundararaja Perumal from Chennai, Professor.
What's that?
This is Dr. Soundararaja Perumal from Chennai.
Oh, thank you, sir. Thank you, sir. Yes, Agilan sir said it. Agilan sir just now said it.
Yes. Professor, thank you very much. Excellent talk. See, we are actually very much fortunate to have you, Professor. We are honored. With
Thank you, sir.
person with 2 PhDs and so much qualification. Very excellent talk, Professor. Thank you very much.
Thank you, sir. Thank you, sir. If I was satisfied, you it's so good, sir. Thank you, sir.
Yeah. Earlier we used to have lectures on laser,
Yes.
laser technology and spectroscopy by one Professor V. Ramakrishnan from Madurai Kamaraj University. You know him,
Oh.
Professor?
Yes, yes,
Professor.
Yes, sir. Ramchandran, sir.
Yeah, he's a very good friend. See, after that we are now hearing equally good lecture from you, Professor. Excellent talk. Thank you very much, Professor.
Thank you, sir. Thank you, sir. Thanks for the compliment, sir. Thank you, sir. Oh. Okay. So, any other question? If possible, I can give the clarification for it. Just otherwise, thanks for your patient listening as well as sparing your ears and mind towards my voice. Thank
Good
you.
evening,
Thank
sir.
you very much. Oh, yes, ma'am. Yes.
Sir,
Yes.
we can use lasers for dissolving the stones in kidney space, sir.
No, because we should not go for laser. What said? Laser crushing, we cannot go for it. Actually, directly we should not go for it. Ultrasound we can use for crushing the stones because it is a soft tissue. If the soft tissue should not be disturbed, so we cannot go for it. The trial is not that much good. Also, we can go for only what's that? We can try ultrasound. Next, only we can go for laser lithotripsy. Laser lithotripsy means if the stone is so hard and the dimension is bigger size means we can use laser for crushing the stones. But in the earlier stage, they will not directly go for it. They will go for only sono or some medicine they will give to clear it. But laser lithotripsy will be applicable for the hard stone with heavy dimension, which cannot directly come through the urethra or through urine. It cannot come means they can use laser lithotripsy. Laser lithotripsy means the litho means stone. Tripsy means that it will be crushed and it will be joined with the urine and it will be expelled out. So directly it is highly useful in destroying the stones of bigger size and what hard materials also, hard material stones. It is useful. Laser is useful in crushing the stones. Kidney stones.
Okay, sir. Thank you, sir. Very nice presentation, sir. Thank you, sir. It's useful.
Thank you, ma'am. Thank you, ma'am. Hello, Pragadishwari. It is clicking and it's going off. Okay. So, hello? Somebody is murmuring and it is not clear to me. Hello? Anybody is there? Okay. Okay. Okay, participants, thank you. Once again, I thank you people for having my voice, and I think that I have reached you to good level. Thank you once again. I thank the organizers once again for giving this opportunity, and thanks for Kanna, who has made this video conferencing very what's that enjoyable one, because from Kadur he has given the connection and all these things, and I take this opportunity to thank Agilan sir and Jaypal sir and his team for giving this opportunity for having a meet with you people through web. Webinar is the biggest chance for us to meet around 450 participants. Very nice it is. So I take this opportunity once again. Thank you all people. Thank you, and thank you.
On behalf of Anna Science Center Planetarium Tiruchirappalli and Tamil Nadu Science and Technology Center Chennai, I really thanks to Professor Jamal Muhammad Zafar from Jamal Muhammad College, Trichy, for his excellent talk on laser and its application on various fields. So this talk will be very much enjoyed by the participants. So we like it. You also give good response. Thank you very much for the excellent talk.
Thank you, sir.
Also, thanks for the participants for your patiently attend the program, and your valuable suggestions in this manner is also received. Thank you very much. Kindly send the feedback form at the earliest, so we will be send you the e-certificate. Thank you very much.
ரெக்கார்டிங்கும் இல்ல ரெக்கார்டிங் ஃபுல்லா ஆயிடுச்சுங்கிற ரெக்கார்ட் எண்ட் ரெக்கார்டுக்கு என்னன்னு கேட்டுட்டு க்ளோஸ் பண்ணிக்கலாம். ஸ்டாப் ரெக்கார்டிங்.
எனக்கு எக்ஸிட் கொடுத்துருங்க, ஃபீட்பேக் ஃபார்ம் மட்டும் ரைட் பண்ணிக்கங்க. அதுக்கு ஓகே நீங்க அப்படியே ரீசெட் அனுப்பிச்சிருங்க. ஓகே அவ்வளவுதானே, யூடியூப்ல பார்த்துக்கலாம். ஓகே சார், ஓகே 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 சார், தேங்க்யூ.
அவ்வளவுதான் சார். பெருசா ரொம்ப ஆகுங்கிற மாதிரி இருக்கும் கடைசியில வந்து. ஆமா அதான்